Hey guys, today we're doing Chapter 4, Section 7, which is talking about scale changes of circular functions, so functions like sine, cosine, and tangent. And we're not really going to get into it too much with tangent, but we're mostly just going to talk about sine and cosine. So first thing we need to do is talk about some vocab. Sine wave is the image of the graph of the sine or the cosine function under compositive translations and scale changes. The pitch is related to the period of the wave. The longer the period, the lower the pitch. So in other words, if you've got something that's like this, where your period's going pretty fast, that's going to have a higher pitch than if you had something like this, where it takes a lot longer to get the period. Okay, amplitude is the intensity of the tone of a wave. It's half the distance between the maximum and minimum of the wave. So, normally our sine function has a minimum at -1 and a maximum at 1. If we change that, then we could also change the amplitude. So the normal amplitude of a sine or cosine function is 1 because it's halfway between -1 and 1, which is a total distance of 2. Frequency is the number of cycles the curve completes per unit of the independent variable. It's calculated by taking the reciprocal of the period. So if you find the period and then you do 1 over that, okay, or just whatever the reciprocal is, that gives you the frequency. We're not really going to talk about frequency very much. Okay, so thinking about really amplitude and period is what we're really focused on in this section. So we talked about period a little bit before in the last section. Now we're going to kind of focus on period and amplitude. So first thing we want to do is sketch a drawing of these equations here on this axis. And the way I'm going to do that is using my prior knowledge from Chapter 3 of my scale changes. So in this function right here, I can rewrite this as y over 5 equals cosine of x over 2. So that is actually just a scale change of 5 in the y direction and 2 in the x direction. Okay, so normally for my cosine graph, I have a minimum at -1 and a maximum at 1. In this case, I'm stretching my minimum and maximum by 5, so I'm going to have my minimum at -5 and my maximum at 5. Okay. Normally with my cosine graph, my period is 2 pi, okay, but in this case I'm stretching it by a factor of 2, so now my period is going to actually be 4 pi. So I'm going to go from -2 pi to 2 pi, and that for this function is going to be 1 cycle, okay. So if I'm talking about cosine, remember that cosine starts at my maximum. So let's see, 3. This is -5. I'm just going to start by graphing my normal cosine function so that you guys can kind of see the change. My normal cosine function goes from -1 to 1. Okay, I have maximum at 1, and then at pi, I'm at my minimum. At 2 pi, I'm at my maximum again. Okay, so this is going to be my normal cosine function. Now with the scale change that I've applied, I've stretched my period out to 4 pi, and I've stretched my minimum maximum out to 5, so I'm starting at my maximum here, and then this is going to be halfway through, and this will be halfway through, so this is going to be that new function, okay? So this would be the graph of y equals 5 cosine x over 2. And notice that I did all of that without a calculator. That's what I expect you guys to do on the quiz or the test. So what is the amplitude and period of the scale change? My new amplitude was 5, because remember it's halfway between my it's half of the distance between my minimum and maximum. So this distance is a 10, so half of that would be 5. Okay, my period my new period was 4 pi because I stretched it by a factor of 2. So basically we've got this formula here, and this is on your formula sheet. I don't really like to think about it this way, but you can. Essentially, this is just saying if you have y equals b sine of x over a and y equals b cosine x over a, the amplitude is always just the absolute value of b, and the period is always just 2 pi times your a value. So what we want to do is match each of these equations with its graph. Alright, so looking at this function here, y over 2 equals sine of x over 2. If I were to think about that scale change would be, let's see, 2 times my x and 2 times my y. So thinking about that, how is that 2 going to affect my period and my amplitude? Well, amplitude is talking about the y directions. So normally I'm going from -1 to 1. In this case, I'm going to go from -2 to 2. So I'm looking for a graph that goes from -2 to 2. And then my period is normally 2 pi. If I'm multiplying that by 2, my new period would be 4 pi. So I'm looking for a graph that goes from -2 to 2 and has a period of 4 pi. So I know that that's going to have to be b. Okay, for number 11, I've got 2y equals sine of x over 2. Okay, so if I were to write my scale change, I would have 2x and y divided by 2. Okay, so I'm stretching my x's by 2 and I'm shrinking my y's by 2. So think about that with my amplitude. My amplitude normally goes from -1 to 1. Okay, so my amplitude is normally 1. So if I'm shrinking that by 2, I know that I'm going to go from a negative half to a positive half. Okay, then with my period is getting stretched by 2, so it's going to be 4 pi. So I'm looking for a graph where I'm going from -0.5 to 0.5, and I have a period of 4 pi. So that's going to be E. Okay, my next one here, if I were to write my scale change, I would have x over 2, y over 2. Okay, I know I just kind of abbreviated that. I'm just trying to save a little time. So thinking about my normal period is 2 pi. If I'm shrinking that by a factor of 2, my new period would be pi. So I'm looking for a graph with a period of pi, and then I'm also shrinking my minimum maximum values or my amplitude by 2, so that would become a half. So I'm looking for something that goes from -1/2 to +1/2, and that has a period of pi. So it looks like that's going to be this one, because I can see that my period here is pi, and I'm going from -1/2 to +1/2. Okay, next one, if I were to write that scale change, I've got x over 2 and 2y. So my period is getting cut in half, so it'll be pi. My amplitude is getting doubled, so I'm going from -2 to 2. So I'm looking for something with a period of pi and going from -2 to 2. That's going to be A. Okay, my next one here. This one's a little bit tricky, because if I were to write my scale change, well, my x is being multiplied by pi over 2. So the opposite of that would be to multiply by 2 over pi. And for my y values, I would be divided by 2. So normally, my period is 2 pi. If I am multiplying my x values by 2 over pi, my new period is going to be 4. Okay, so this one will have a period of 4, and I'm going from -1/2 to +1/2 because I'm shrinking my amplitude by 2. So looking for that graph, that's going to be C. And then the last one here, again, this is a little bit weird. So for my x values, in this case, I'm multiplying by 2 pi, so that'd be like dividing by 2 pi, so x over 2 pi. And then my y values, I'm multiplying by 2. So thinking about my period, normally my period is 2 pi. Well, if I'm dividing each of my x values by 2 pi, that's just going to be 1. So I supposed to have something with a period of 1, and my amplitude is going to go from -2 to 2. So that looks like it's going to be this one here, F. Alright, so that is everything for section 7.